Matter, elements, and the periodic table. We take these notes periodically. Okay guys, this is a quick refresher for most of you, but let's get back to basics here about what exactly matter is. Matter is everything around you. It's the air that we breathe, it's the clothes you wear, it's you, it's me. It's anything that has mass and takes up space. It's made up of the different combinations of all the elements that are on the periodic table. And matter is basically particles that you cannot see without a microscope. Now, energy is different. Energy is the ability to do work. It does not take up space and it has no mass. For example, the light from the sun is energy. Everything in the universe is either energy or matter. Alright, the atom. The atom is the smallest part of an element. It's very, very, very tiny. Imagine like 1 grain of sand on a beach contains more atoms than there are sand grains on an entire beach. Wow! Does that blow your mind? Atoms of each element have identical properties. An example of that is like all hydrogen atoms are all identical. They're all hydrogen atoms. Alright, so if we have an atom and we're looking at the different parts that make up an atom, we'll start in the middle, and that's the nucleus. The nucleus contains the protons and neutrons. Protons are positively charged, and they're all identical in an element. And their mass equals 1 AMU. And all AMU stands for is atomic mass unit. Neutrons, along with protons residing in the nucleus, have a neutral charge. So if you can remember, the NEU in neutron is kind of identical to neutral. Neutrons are neutral. They're all identical also, and their mass is also 1 AMU. Alright, now we have the electron cloud. And out in the electron cloud are the electrons. And electrons are negatively charged. They're very, very, very tiny. In fact, we don't even have a measurement for them. We just say that they are 0 AMUs, or 0 atomic mass units. Okay, so the element. There's a reason why they call it the periodic table of elements. It's because a bunch of these things called elements make up this table, this model that we have that represents all of the substances on Earth. So an element is a substance that cannot be broken down into any other substance by chemical means. And if you've ever seen the Bill Nye video where he takes water and he separates it into hydrogen and oxygen, well, that's separating it into 2 different elements. Water's chemical makeup is H2O. So water's not an element. Water is a compound made of 2 different elements. So that compound can be broken down into a simple substance. Elements are made of atoms. An example, the element gold is made of gold atoms, and the element neon is made of neon atoms. On the periodic table, these elements are represented by 1 or 2 letter syllables. An example, hydrogen is H, carbon is C, aluminum is Al, and sodium is Na. What I want you to notice is that anytime there's 2 symbols, the second letter, anytime there are 2 letters, the second letter is always a lowercase letter. That's how you know you have a new element. So if you're looking at a formula, some sort of chemistry formula, and you see the letters there, as soon as you see a lowercase letter, well then you know the letter before that goes along with it. All matter is made up of about 119 different elements, and that number has changed. It's in the 120s now. They can be alone, or they can be a combination of elements. and the periodic table contains information about each of these elements. Alright, so how do these elements join together, and what's it called when they are joined together? Well, this is called a chemical bond. So chemical bonds hold atoms together kind of like glue. It's almost like gluing them together. When a chemical reaction occurs, chemical bonds are being formed or broken apart. And during this process, atoms are reshuffled. An example, hydrogen and oxygen gas, or O2, equals H2O. This is the reaction of turning oxygen and hydrogen into water. Okay, so we talked about a chemical bond. So when chemicals bond together, they can form a molecule. And a molecule is just two or more atoms put together. They could be the same atoms. So molecules can be the same atom together, like O2, for example. And they could also be different atoms together, like H2O. So when you have more than one atom put together, chemically bonded, this is known as a molecule. Alright, formulas and equations. So a chemical formula shows the ratio of elements. In other words, how many atoms of each element are in the compound. And they're written as a subscript. These are like small numbers below letters in compound. Examples, O2. That's oxygen gas. CO2, that's carbon dioxide. H2SO4, sulfuric acid. Can you tell me how many different elements are in sulfuric acid? Yeah, hopefully you said 3. You don't see any lowercase letters, right? So those are 3 capital letters. Therefore, those letters represent 3 different types of atoms, or 3 different elements. Can you tell me how many atoms are in sulfuric acid? Alright, hopefully you figured out that there are 7 atoms total. 2 hydrogen, 1 sulfur, 4 oxygen. Alright, chemical equation. These are just a short, simple way to describe a chemical reaction. Uses symbols and formulas instead of words, like C plus O2. So carbon plus oxygen gas equals CO2. Compounds and mixtures. Alright, compound is a substance made of 2 or more elements chemically bonded, or chemically bound, that's stuck together. They cannot be separated by physical means. So examples are table sugar, hydrochloric acid, sodium chloride, also known as salt. Properties of a compound can be very different from properties of the elements that make up the compound because of a chemical change that has occurred. And you guys know from what you've learned already that sodium chloride, if you take that chlorine and that sodium separately, if you tried to eat either of those things, you would poison yourself because they are very dangerous alone. But if they're compounded together, then they can make something that a lot of people eat every day, salt. Alright, now let's talk about mixtures. So a mixture is made up of 2 or more substances in the same place that are not chemically combined. Some examples of a mixture could be like Chex Mix or like Lucky Charms cereal. You could easily separate the marshmallows from the oats, because it's a mixture. Other examples include soil, like you can remove the gravel from the rest of the dirt, ocean water, or even the air we breathe. Each part of a mixture has its own properties because there has been no chemical change or bond. Another example is Kool-Aid. Sure, you can mix up Kool-Aid and it's delicious and the color changes and all that stuff, But if the water evaporates, the Kool-Aid residue would be left behind. But another way, or another indicator, or a lack of indication that it's not a chemical change is that when you mix that Kool-Aid into the water, there's no fizz, there's no pop, there's no smoke. There's nothing that's letting you know, there's no indication that there is a chemical change occurring. And that's because it's a mixture.